Yeah, that's what she was asking. It's the one that's like 20
Alright, thumbs up if you got number 1 right all by yourself. No, it's not. Well, but your result has a plus sign? Does your answer completely match this? No. So yeah, you just crossed an x, and a y, and a y, but you have to put it in factored form. No. For sure, I would say by Friday. For sure by Friday. So, I mean, they usually end within a week. Okay, so there was questions about number 2, like, what should I do first? Should I reduce up and down? Should I reduce diagonally? Should I rewrite it? And there's, I mean, you can do lots of things. I'm tempted to reduce up and down and diagonally, but yeah, let's just do that. I'm going to reduce these numbers here. So like 7 goes into 7 once and 21 3 times. So these are both divisible by 7, so I did it. Now 14 and 12 are both divisible by 2, so I'll reduce those as well. Now, more than one right way to do this. But now I'm going to multiply across and make this one fraction. Making 7w x squared y to the third z to the fourth over 18 w to the sixth x squared y to the fourth z squared. So I consolidated the variables because it's so many. I just went right across, and instead of trying to reduce all these ways, I just went ahead and consolidated into one fraction, adding exponents. So y with an invisible 1 here, and y to the third makes y to the fourth in the one big fraction. And now I'm going to reduce. So 1w up top and 6w's down below. Keep in mind you can, as much as you want, you can write out these variables. You know, one of them will cross out, leaving 5 in the denominator. As much as you want, you can do that. With the x's, x squared over x squared, that's just 1. You know, both cancel. You got 3y's over 4y's. 3 will reduce, leaving 1 in the denominator. Really, it can be done mental math. Realizing that even sets remaining top and bottom to stay in their top and bottom. 2 more. So we're switching from multiplying and dividing to adding. Adding requires a common denominator. So you need to figure out the least common multiple, a high number that everything can divide into. Who picked the right LCM? Anybody? If you pick 60, that's okay. You can still get to the right answer with 60. But since 6 and 10 can both go into 30, 30 would be the least common multiple, but you can pick 60. No, we're going to multiply in what we're missing. So I'll multiply 6 times 5 to make it look like a 30. We need to get to a squared, so I'll put in another a and I'll put in a b squared.
Oh, never mind.
And that's your adding. One more question and then we'll... You guys finished the assignment in class Friday, but I did not give you credit for it, so I'm going to have you open that up just so I can walk around and give you the points. And then we're going to do some simple graphing today. There's complicated graphing. There's some very complicated graphing in this chapter, and then there's some simple graphing, and today is the simpler form. Alright, so we need to factor. I'm going to look at these denominators in factored form.
Oh, there's one more, Bower?
Last question. Alright, I'm gonna factor. Two of you have your fingers on? Alright, there's the factored form of each denominator. -7 and +5, +5 and +4. So my common denominator has to include every factor.
Miss Goblin,
Yeah.
on solid quizzes, does it matter if the variable's correct or not?
No, it doesn't. I feel like if somebody did like a digital time capsule of this year or maybe 5 years, they should put that noise in it, you know? Like if you played that noise in a classroom like 30 years ago, they would think like the turkey is done because it sounds like an oven timer, like an old school oven timer, you know? And you guys think of like a iPhone, like I wonder in 30 more years, like if that noise will mean anything to anybody. Like we all know exactly what's going on, but in a different place and time, we like has a different meaning. Like how old will you be in 2060? Does 2060 seem like future to you? Doesn't seem that far. 2080?
And we're in that year and it's nothing like that. That's Dude, I am. Oh, I don't know. Why would you ask it? You would not be allowed to get
It is a fence.
Okay, so
No.
you don't have to do it every time, but I wanted to because this graph so we've been doing these problems like in Bell where you're working with fractions that aren't regular fractions, they have the variable in the denominator. So what we're graphing here is like the most basic fraction with the variable in the denominator. This is called a reciprocal function, and it's a fraction with the independent variable in the denominator. And that's as simple as it can get. We're going to put more numbers into that equation, but this is the one that we're going to compare to. This is the parent function, which is y equals 1 over x. Yeah. Undefined. Very important. What's that? You cannot graph undefined, so it represents a break in the graph. Let's put an asymptote there. Yeah. No, as soon as I put another number in there, it's something else. This time, what number would be undefined? 4. So for this one, our table would have to go 1, 2, 3. 4 will be a break. 5, 6, 7. That would be the other half. Splits in 2 halves based on the undefined value. So it's a little bit weird with these fractions. So we have negative 1/3. Negative 2, negative 1/2. Negative 1, negative 1. Yeah. You can put an asymptote here. I messed that up pretty good. Numbers are kind of a bummer, all these fractions. Well. So with these 3 points, you're not able really to get a good graph. You have to know the shape of the graph and be expecting it to really to get this right. Unless, it might help to even go up to 4. Like maybe, like what would happen if x was 4? 1/4 or -4, -1/4. So like maybe those points would help us. So we're getting closer to 0 because 1/4 is less than 1/3 and 1/2. So over here it's just gonna keep getting closer and closer to 0, and it'll never touch. And then because x can't be 0, y also will never be 0. So there's 2 asymptotes. X equals 0, y equals 0. To the 0. Yeah, you can put it in Desmos if you want. So we're gonna curve down and then meet at the end. Start near a dash line, curve down, end near a dash line. So on both sides, so these are called branches. This graph is split into 2 branches. On both sides, the line gets very close but doesn't quite touch or cross. So your domain is everything excluding 0. And your range is everything excluding 0. Yes? No. No, it won't. Like if there was a 4 down here, it would be everything excluding 4. Yes.
So everything but the 0 stays the same for your domain and range?
Mm-hmm. Alright, let's do another one. Let's do one with transformation. Oh, no. Here, I'll just write this down. Alright, so h and k, just like every other function. So the number down here will shift the graph right or left. The number at the end will shift the graph up or down. Remember that horizontal translations are always opposite, and they do define the domain. And vertical transformations define the range. So it doesn't always have to be one numerator. If there's a number here, like let's say a was 5, the this one's negative. Alright, if the x is negative up top, the branches are on the other quadrant, in quadrant 2 and quadrant 4. If you kind of look, this is like a negative slope, whereas the one we just did had like a positive slope. So the branches can reflect. But if it changed to like -5 over x, it would be like like the curve doesn't like dip in as much. It's like further away from the axes if you have a number up there. Ready to try one? Okay. Oh, do you guys want step?
Now we go. I'm gonna try that.
Actually, step one is different than every other graph we've done.
How do you find the range? Like what? Oh wait, different. Even. Oh yeah, even.
Step one is actually really important. So typically we plot points first, but here it's advised that you draw the asymptotes before you even plot any points. So once you identify the asymptotes and the domain and range, then go ahead and draw the dashed lines in. After that, you make a table. You plot your 4 points. You draw your line specifically by starting near a dashed line and ending near a dashed line. So I'm going to keep these steps up here and put the next example on the board so you can have a step at the same time. So we're going to use those steps to make this graph. So identify asymptotes. Step one.
How did I just get a 0, 1, 1, 2?
Okay, so identify asymptotes is step one. So here it is on this example. I'm going to say that x can't be 4 and y can't be 3, so those are our asymptotes. Can anybody just come up with a reason that y could not be 3 in this equation? It's mathematically impossible. Torian, go ahead. Right, this will never equal 0. Since this never equals 0, the whole thing will never equal 3. It'll get very close to 3, but it'll never perfectly equal 3. So I'm going right forward up 3. No, I like that you should think, like, why couldn't this be 0? Like, what could we plug in to make it 0? You know? You put a 4 in there, and you have this situation. And that's called undefined, and that's not a function.
Are you serious?
Yeah, undefined doesn't work. This we would accept, and that equals 0. But this equals does not exist, is what this pretty much equals. It won't work if they can't do it. So that's why. So I'm really glad you questioned it. You gotta question it. Alright, so okay, so I'm supposed to do asymptote and domain and range of step 1, so alright, draw the asymptotes is step 2. I don't plot points. That's my first step with these graphs. I do dashed lines first. So a lot of people can get by getting the majority of the points just by knowing where the dashed lines go. Like, they're not so good at the tables, but for this particular type of function, if you can get the dashed lines in the right place, right now all I have to do is a curve here and a curve here. So sometimes people just make it up. They skip the table and just curve and curve. So that's step 2. Step 3, make a table. The reason they skip the tables, they just cannot pay attention this long. They're lost by this point. How do you make a table? What goes in the table? We're going to put 4 in the middle. And next to 4, we're going to write undefined. And then we'll do 2 left and 2 right. Let's see what this math looks like. So our equation is 2 over x minus 4 plus 3. 2 over 2 minus 4 plus 3. 2 over negative 2 plus 3. Negative 1 plus 3. 2. So we have a point at 2, comma 2. Take it one step at a time. It's not really that tricky and simplifying, Jackson. You do 3. Plug 3 in, tell me what you get out.
Why did you do 2, 3, 4, 5, 6, and not negative 3?
It's a great question, Matt. You're right on time with that question. We put the asymptote in the middle. This, that x can't be, that's got to be the middle of your table, or you'll only end up with one branch. People just end up with this, and they have no idea why. You gotta have the middle, which is the dashed line, or all your points are just gonna show half the graph. Just gonna draw a huge line here. How'd it go, Jackson? You got 1? You got it right. It's 1. Okay. Not bad. Gabby, did you do 5 yet? What'd you do? 5. Math really isn't too bad. It looks intimidating, but step by step, it's okay. Seth, you do 6? What is it? Oh, you mean you understand. 6, 4. Okay. So the reason for this particular graph, step 1 and step 2 have to do with asymptotes and not points, is because points without the dashed lines just look like a pair of dice. Just random. So it's all about connecting your points using the dashed lines as a guide. You put your pencil near a dashed line, like it's not even just about hitting the points, it's about starting near a dashed line, moving through the points and ending near a dashed line. Start close to a dashed line, move through the points, and end near a dashed line. Because if we were to continue our table to include much more points, it would just lead us closer and closer to these dashed lines. And that's how you graph a reciprocal function. So I'll be happy to go ahead and start your assignment with you. Instead of putting up another example and being rushed to finish it, I'll be happy to start your assignment with you. Here. I think I'm going to do 4 since I haven't done a negative. Or just set up the table and some points for you. Give my permission to use a mixed number.